All right, so now we're starting with calculus. All right, calculus is usually the study of, it's a mathematical branch where you're studying the rate of change of something. Um, I'm not going to go into theory that much. I'm going to start with the first concept in calculus, which is limits. All right, the limit of a function. So the way you would write the limit of a function is you would write lim as in the limit, and then you're going to write the variable approaching a specific value, say, like, for example, 6, and then you're going to have your function here, say, for example, x plus 3, all right? Something very simple like this, all right? So this is the limit of function. Okay, this is how you would see it. The way you would find, first of all, what does this mean? This means we want to try to find this function, all right? This function over here. We want to find as this function, what value does it approach or get close to بما معنى when you plug in the value 6 as a value of x is going approaching to 6. All right, this is what this basically means. So in this case, we are just going to substitute the value for 6. So the limit as x approaches 6 of x plus 3 is 6 plus 3, and the answer is simply 9. It's very straightforward, very simple. Another example, let's say we have the limit as x goes to 9 for, let's say, the square root of x. All you are going to have to do is plug in the value of 9 in the function. So it's going to be 9. Square root of 9 is equal to 3. All right, and this is how you can solve for almost any basic limit. Okay, but let's say we have a function like this. This is where limits will get a bit more challenging, I want to say. So let's say the limit as x approaches 0 of square root of x plus 5 minus the square root of 5 over x. Okay. Now, if you notice, if we wanted to plug in the 0, we are going to get 0 plus 5 minus the square root of 5 over 0. And we all know we cannot divide by 0, so this function does not make sense. Okay. That does not mean the limit does not exist necessarily. It depends on the cases we get. In this case, this I would call case 1. When you have a square root at the very top, all right? When you have a square root and x inside of it, square root of x. In this case, there is a method of simplifying this formula or this equation or this function in a way that we will not get x by itself, or the denominator اللي هو اللي تحت يعني ما بيكون صفر. It will not be equal to 0. So how can we do that? So there is something that you guys need to know called the conjugate. Okay, what does this mean? So let's say for this function, square root x plus 5 minus square root of 5. All right. The conjugate of it will be equal to, so the conjugate will be equal to the square root of x plus 5 plus the square root of 5. What changes here is the sign goes from minus to plus. It's always going to be the opposite sign. So if it's minus in the beginning, it's going to become plus at the end. If it was plus here, it will be minus. This case is only used, the conjugate is only used when we have a square root of x. All right, square root of x. This is when it is used, whether it is in the numerator, yani in this case in the top, or in the bottom, depending on the question, how it shows up. Okay, so this is the first case. So what are we going to do with this conjugate? So this was our equation, limit of square root of x plus 5. Let me rewrite it here. So if we're just looking at the function, all right, so it's going to be square root of x plus 5 minus the square root of 5 over x. So what is the idea of الconjugate? احنا ليش قاعدين نطلع الconjugate؟ احنا نبغى نضرب فوق وتحت with this conjugate. All right, so that is the whole point. So we're going to be multiplying up and down by square root of x plus 5 plus square root 5. Okay, the conjugate. And anything you're multiplying up, you have to multiply down لأن احنا ما نبغى نغير equation. We're not trying to change the equation. We're trying to keep the function the same as it is. Right? So this will be your very first step, finding the conjugate and then multiplying your up and down by the conjugate. شو اللي بيصير هني؟ بيستوي up we have square root x plus 5 minus square root 5 times square root of x plus 5 plus the square root of 5. Okay? All over x تحت square root of x plus 5 plus square root of 5. Okay? It's the same equation. I just put them in brackets under the same. Anything we multiply up will stay up. Anything we multiply down stays down. Okay? So what is the point of doing this? So if you look at the numerator الحين where we multiplied the conjugate of the number, عندنا احنا هالform. عندنا احنا a minus b times a plus b, and this, all right, is a general mathematic formula which is equal to a squared minus b squared. All right, you guys can, if you want, just distribute. يعني تقدرون بس توزعون لو حبيتوا. زين، بس بتطولون وايد في التوزيع بشكل عام، وخاصة ويا سكوير روت عادي يعني ما تخربطون وايد ويا السكوير روت يوم قاعدين تسوون التوزيعة. So don't just distribute, memorize this form because this form will be very helpful in the case of limits. في هالحالة, if we're looking at our a value, all right, I'm going to highlight by blue, the a value, our a is square root x plus 5. Okay, this is our a in this case. Our b, if I'm going to highlight our b over here, our b is the square root of 5. Okay, so if you notice now, this is also square root of 5, which is the b, and this is square root of x plus 5, which is also a here. So we have the same form on the left-hand side here, اللي هني عندنا إياه, this form. We have it in the equation at the top. One of them is minus and one of them is plus. Same thing here. One of them is minus, one of them is plus. This is why we wanted to multiply by the conjugate. Tamam? So what will be the solution of the top part? It will be this right here, which is a squared minus b squared. All right? We know that our a value is equal to square root of x plus 5. So a squared is going to be equal to square root of x plus 5 squared. And if you remember from before, if you have a square root and a square, they cancel each other. So this will go away with this, and you will get your final a squared is equal to x plus 5. تمام؟ فعندكم الحين هذا هو ال a squared value. يعني this value, then you can plug it in back in a squared. Let's do the same thing for b. So for b, we know that b is equal to square root of 5. b squared will be equal to the square root of 5 squared. So b squared is going to be equal to نفس الفكرة. هني we can cancel the square roots. It doesn't matter. It's a constant. تقدرون تحطونه بعد في الكالكوليتر وتطلعونه. انزين. And you're going to get 5. So now we have our a squared and b squared because that is our solution. So our b squared, we are going to put it in here. تمام? So now if we want to simplify this whole part, all right, we are going to put our a squared minus b squared in its place. A squared is x plus 5. Okay, this is our a squared minus b squared, which is 5 that we found here. All right, فعندنا x plus 5 minus 5, And at the bottom, it's going to stay the exact same way. هذا 5, again, this is just our b squared. قاعدين نستخدم احنا هالايكويشن عشان we put it back in. And at the bottom, we will leave it as it is. So it is going to be x into square root x plus 5 plus square root of 5. تمام؟ الحين if you notice the top part, if we want to just open the brackets, بيكون عندنا x plus 5 minus 5 divided by x into square root of x plus 5 plus the square root of 5. تمام؟ okay. 5 minus 5 becomes 0. So this part is to be 0. صح ولا لا? 5 minus 5 is equal to 0. So this will be equal to x over x into square root of x plus 5 plus square root of 5. The whole idea now is you can cancel the x up and the x down, and you will get an equation that looks like this. So x divided by x, that's going to be 1 remaining up over square root of x plus 5 plus the square root of 5 at the bottom. And then remember, this isn't what we are trying to find. This isn't our final answer. The question was to find the limit as x approaches 0 of this function. فإحنا we simplified now this function to this form, and now we can apply the limit to it without getting 0 in the denominator. So the limit as x approaches 0 of this is going to be equal to 1 over, إذا حطينا الحين الزيرو بدال الx بيستوي square root of 0 plus 5 plus the square root of 5, which is equal to 1 over 2 square root 5, or it is also equal to the square root of 5 over 10. That doesn't matter. As soon as you put this in the calculator, this will come out as your answer. But this is the point. So now if you notice, the limit is no longer 1 over 0 or a value over 0. You're no longer dividing by 0. So this isn't the actual limit, all right? So this is wrong. You cannot plug in 0 directly. That's why we simplified it in this way using the conjugate عشان نقدر نطلع the actual limit, which is square root of 5 over 10. All right? This case only you can apply the conjugate مثل ما قلت if you have a square root or an x under the square root in the numerator or denominator, it doesn't matter. يعني يا فوق يا تحت، طالما عندكم square root of x فوق تقدرون تطبقون هذا القانون. وطبعا لازم يكون في شيء يمه لأن we are flipping the sign. So if it's only square root of x plus 5, you cannot do anything. All right? So when you have this form, this case, you can apply the conjugate, multiply it up and down, simplify it using this equation of a minus b, a plus b. All right, دائما هذا بيكون a value مالكم وهذا b value مالكم. You square them both and you will get this minus, it is always minus b squared, which is 5. بعدين you simplify this equation all the way until you find it in a form where something in the numerator will cancel with something in the denominator وبعدين بتحصلون جوابكم. Let's do another example of this. Since someone already asked in the chat to do this, let's do the example they sent. So it's of the limit of x as it approaches 0, all right, of this equation, which is square root of x plus 38 minus the square root of 38 minus x divided by x. So obviously you cannot just put 0 زين لأنه بيستوي بعدين division by 0, so we cannot do that. So what do we have to do? We have to simplify this using the conjugate. So what is the conjugate going to be equal to? If this is minus, and here we have minus, so the conjugate is going to be square root of x plus 38 plus the square root of 38 minus x. This is your very first step, okay? Finding the conjugate. The second step now is multiplying the conjugate up and down in this equation. So the equation is square root of x plus 38 minus square root of 38 minus x على x. وبنضرب فوق وتحت with the conjugate, which is square root of x plus 38 plus the square root of 38 minus x. All right, again, just remember the signs are opposite, over the same conjugate again, which is x plus 38 plus the square root of 38 minus x. Simplify, بيبقى لنا square root of x plus 38 up minus 38 minus x times the square root of x plus 38 plus the square root of 38 minus x. تمام? So we have it in the same form as we did earlier, and تحت, do not simplify at the bottom, just plug in, just put it in brackets and multiply. So يعني square root of x plus 38 plus the square root of 38 minus x. All right. Now we have this form, a minus b into a plus b يساوي a squared minus b squared. So the a value, all right, our a value is square root of x plus 38, and our b value is the square root of 38 minus x. All right, again, this is our b value. These values are the b value, and this is our a value. Okay, same as in the equation. فالحين احنا we want to find a squared and b squared. A squared is going to be x plus 38. Let me actually do the steps so you guys don't get too confused. So let me move this down here and this up there. So how did I reach to a squared is equal to x plus 38? Because when you square a, it is the square root of x plus 38 squared. مربع. وهني بيتكنسل السكوير روت with the square. Alright? بيتكنسلون بيبقى لنا x plus 38. At the bottom, for b, I mean, sorry, b, it is going to be b squared, which is square root of 38 minus x squared. So b squared is going to be 38 minus x. Again, square root cancels the square. And now we can plug it in back here as a squared minus b squared. All right? So it's going to be a squared minus b squared بدال كل هالخرابيط. فعندنا a squared, which is x plus 38. All right, this is our a squared, minus b squared, which is 38 minus x. This is our b squared. All right. Keep them in brackets so you guys don't get confused with the signs later on. Over x, the denominator does not change, اللي هو square root x plus 38 plus the square root of 38 minus x. And that's pretty much it. Now we can simplify up. So x plus 38 minus, we're going to distribute the minus. فبيصير minus 38, and minus becomes plus x over. At the bottom, we do not touch it. We keep it as it is, plus the square root of 38 minus x, like this. So if you notice here, we have 38 minus 38. It will become 0. So what will be left up? It's going to be equal to x plus x, which is 2x, all right? X plus x, which is 2x, over x square root of x plus 38 plus square root of 38 minus x. منجيسة اللي تحت. ليش؟ لأن now if you notice, we can cancel the x we have up and down with each other. So now when we simplify this, this is going to be equal to 2 over the square root of x plus 38 plus the square root of 38 minus x. تمام؟ Now, this isn't our final answer. We did our cancellation, but the question was to find the limit as this approaches 0. All right, so we need to find the limit of this as it approaches 0. So we're going to do the limit as x approaches 0. Now we can plug in the 0 in the bottom. So we will have 2 up top, square root of 0 plus 38, plus the square root of 38 minus 0. Or in other words, it's equal to 2 over 2 square root 38. معناته, if you put it in the calculator, you're just going to see that it is 1 over square root 38, which is the square root of 38 divided by 38. All right. Again, in the calculator, it will never give it to you in this form. This is something they called rationalization. It's just a notation. يعني هو automatically عدلة ورتبة إنه يخليه في هالform. So you guys have to understand how to do it by yourself just in case. لأن you guys have a multiple choice exam, and if I'm not mistaken, in the multiple choice, it is given as this to be your final answer. So 1 over square root 38 is your answer. Is this clear? So whenever you have a square root up top with a minus or plus, you're going to find your conjugate. You're going to multiply up and down with conjugate. You're going to simplify using a squared minus b squared. Whatever values you get up there, you're going to simplify them. And then you're going to cancel a component up and down, whatever it is. وبعدين, you will plug it, you will do the limit of whatever your simplified function is, and you will find your actual limit. All right? So this was case 1, in the case where you have a square root صارت المفروض 2x. Now we canceled the x. لا هني, if you notice, here we have x, all right, and here we have an x. So x plus x صاير فيساوي 2x. حلو. 2x هني الx والx بيتكنسلون ويا بعض. We're not doing 2x minus x equal x. We're not doing this. And we're doing x divided by x. يعني 2x divided by x. هذه هي الفكرة. Now this was the first case. All right. العفو. The second case is, let's go down here. Case 2. Okay. Let's call this case 0. بس عشان ما تخربطون. This is case 0, which is the easiest case. And all you have to do is just plug in the value and you get your limit. You don't need to do any simplification or anything like that. That's all you have to do. All right. Case 1 is when you have a square root and you cannot find the limit directly. Yani this is when you get 0 in the denominator, okay? If you don't get 0 in the denominator, you don't have to do the conjugate steps وكل هذا. You can just solve it. You can just plug in the value. But when you get 0 in the denominator and you have a square root, هني معناته you use your conjugate. This is what case 1 is. Case 2, again, if you get 0 in denominator, right, يعني 0 down, يعني 1 over 0 مثلا. Okay, if you get this case, but let me find the question where this is the case. Let's look at this one, for example. The limit as x approaches -3 of 2x plus 6 divided by 4x squared minus 36. Okay? For example, let's look at this. Then, now, if you notice here, if we wanted to plug in the -3, all right, we see 2 into -3 plus 6 over 4 into -3 squared minus 36. مو مهم اللي فوق أبدا. I'm not going to simplify it even. Look at the bottom. It is going to be 3 squared. معناته 4 times 9 minus 36. معناته doesn't matter what the top is, it's going to become 36 minus 36, which is equal to 0. So we cannot do this. We cannot substitute because this is the case of dividing by 0. All right? we're gonna get 0 at the bottom. But we cannot just plug in هالvalue. ما نقدر بس نركب نحط هالvalue داخل ونقول it's the limit does not exist. The limit does exist in this case as well. But how can we simplify it? Case 2 is factorization. All right? Factorization or finding common factor. These are the two ways you can do it, by factorization or also finding the common factor, which is a part of factorization. So let us look at just the function هنا. زين. The first thing that I notice is the top. I have 2x plus 6, right? I can take the 2 outside as a common factor. يبقى لي x plus 3. And how did I reach this point? Let me show you. So for just the numerator, okay, we're just looking at the numerator right now. زين. How did I figure this out? So what did I do? I divided 2x plus 6. I divided all of it by 2. So I divided this by 2, this by 2. So I can take the 2 outside as a common factor. All right? This is how تاخذون العامل المشترك. نفس الفكرة. This is how you do it. So you will cancel up and down. هني بيستوي بس x باقي لنا. And 6 divided by 2 is equal to 3. All right? That is how we got 2 into x plus 3. All right? This is how you take the common factor. So this is what I did for the top part. The top part is 2 into x plus 3. All right? Let's do the same thing for the bottom part الحين. خلينا ناخذ الأربعة common. فأربعة بيستوي. If you do the same exact idea, it's going to be 4 into 4x squared minus 36 divided by 4 divided by 4. الأربعة والأربعة بيتكنسلون بيبقى لنا x squared في البداية. بعدين 36 divided by 4 إنزين 36 divided by 4 يصير 9. So this becomes x squared minus 9. All right? So this is how you find your common factor. Now this is the first step. The second step is الحين عندنا تحت x squared minus 9. If you remember early on I was showing you this formula اللي هو a minus b into a plus b يساوي a squared minus b. يعني العكس بعد بيكون صحيح اللي هو a squared minus b squared is going to be equal to a minus b times a plus b. All right? It's the same meaning. هني شنو ال a squared value اللي عندنا إياه؟ a squared which is equal to x squared. عندنا minus في النص وبعدين عندنا ال b value مالنا هني اللي هو b squared is equal to 9. ال b. So we are going to do the opposite now. Now we want to find a and b. To find a squared equal x squared صح؟ To find a, we need to do the square root of both sides. Anything you do on the left, you do on the right. And when you do that, you notice that you can cancel the square here and the square here. بيبقى لنا a is equal to x. Same thing for b. So b squared is equal to 9. We need to cancel the square, so we do square root for both sides. بيتكنسل هني square root. For b is equal to the square root of 9, which is 3. So now we have our values for a and b. But why are we finding these values? So now we can use this formula and substitute our a and b values in the factorized form. يعني احنا we want to do the factorization, which is factorizing into this form over here. So what will happen is the numerator will not change, which is 2x plus 3. Denominator مالنا, the 4 is outside as a common. All right. The first part, so this is our a squared minus b squared. All right. This is in the form of a squared minus b squared. فاحنا نبغى نحطه in a minus b and a plus b form. فبيكون عندنا two brackets at the bottom. a minus b will a plus b. What is the value for A? It is X. What is the value for B? It is, in purple, it is 3. And we have 1 minus and 1 plus. This is the way you do the factorization. يوم يكون عندكم هذا الform. All right? You have to use this equation and apply it, and you have to make sure in between it has to be minus to be able to use this form. تمام? So if I just rewrite this in the same way, this is 4x minus 3 into x plus 3. Now you notice up and down, what do we have the same? شو اللي عندنا نفس الشيء؟ x plus 3 x plus 3, they're the same thing, so we can cancel them together. So we will be left with 2 divided by 4 into x minus 3. All right? So now we cancelled a part up and down, similar to what we did before, اللي هو مو الفactorization هني اللي هو conjugate ما conjugate. Here we were cancelling the x up and down. So now here we are cancelling our x plus 3 up and x plus 3 down. Once we reach this step, we simplify, and now we can find the limit as the question asks, which is the limit to x minus 3 of 2 over 4 into x minus 3. يعني بنعوض بيستوي 2 over 4 into minus 3 minus 3, which is equal to 2 minus 3 minus 3, 1 over 12, minus 1 over 12, yes. Okay, so minus 1 over 12. Just put it in the calculator and you will find it. تمام? Is this clear? Again, very quick recap. في البداية, I plug in the value, check if the denominator is 0. All right? Check if denominator is 0. هاي أول step you have to see. إذا كان 0 بعدين تطبقون الفactorization والfactoring في هالحالة. So since we checked it, we saw that the denominator is 0. We have to factorize this. The first thing I did was I took a common factor, العامل المشترك اللي هو 2, in this method, and then I will be remaining with x plus 3 and up. Same thing I did down. I took 4 common factor, بيبقى لي x squared minus 9 inside. And then I applied this form, or actually this form, of a squared minus b squared, because that is what we have at the bottom here. We have a squared minus b squared, which is in this form over here. Okay? This x squared minus b squared, then I identified my a اللي هو في البداية والb اللي هو ثاني واحد, found my actual a and b values, and then I plugged into this formula to substitute بداله. So عندنا هني a minus b and a plus b. Then you notice that we get to cancel one of the things. Once we cancel, then we can plug in back the limit value and we find our final answer. Any questions about this so far? All good? Insane. Let us see here. I have a question for you guys. أبغى إذا بتردون عليه الحين ولا لا. The limit as x goes to 7 of x squared minus 21 over x plus 2. Which case is this? Is this case 0 or case 1 or case 2? Which case يطبق هني? Case 0, case 1, case 2. Case 0 يعني you just substitute, directly find. Case 1 لو تذكرون square root of x. Or case 2 factorizing the formula. Remember, before you move on to case 1 and case 2, check for case 1. Check. Substitute the value of 7 inside. See what happens. فبيكون عندنا 7 squared up minus 21 over 7 plus 2. Since we are not getting any value in the denominator that's equal to 0, معناته خلاص, that's it. So it's going to be 49 minus 21 over 7 plus 2, which is 9. So we can just simplify this and find our final answer. That's it. So you don't have to go over any more steps. And that's your final answer, which is 28 over 9. So it is case 0. All right? Don't just see x squared or x plus 2 or حتى لو شفتوا square root, even if you see square root, that doesn't necessarily mean that you have to go to case 1 or case 2. You just have to plug in the value first, check for the denominator. When the denominator is 0, that's the only time you will start solving in the form of case 1 or case 2. All right? Let us look at another one. All right, this is a good one. So, the limit of x as it goes to 8 of x squared minus 5x minus 24 divided by x minus 8. All right. So again, the very first step is you're going to check if you can plug in 8. But obviously, without even looking at the numerator, if you put 8 for x, you're going to get 8 minus 8, which is equal to 0. So we cannot do that. So this is not case 0. We don't have any square roots. This is not case 1. This is case 2. If it's not case 0, it's not case 1, it is automatically case 2. All right. So this will be factorization. So if we look at this formula, this is, if you remember, a quadratic equation, and you need to factorize this quadratic equation. You can do that using mod 5.3 if you want, all right, by putting 1 minus 5 and minus 24. But I do not recommend doing that because sometimes you get a value for a here, all right? فإذا عندكم, if you remember from before, if your a value here is equal to 1, all right, just use mod 5.3 and you're going to be fine, okay? You can use mod 5.3 and you're going to be fine. But for the sake of this example, I want to do the full factorization method just for people who want to understand the full factorization method. So to factorize a quadratic, so we're just looking at our numerator, all right? We want to factorize this quadratic equation. Our C value is equal to 24, or minus 24, I should say. And our B value is equal to, remember, it's A, B, and C. صح ولا لا? So let me actually color code so that it's a bit clearer. C is equal to negative 24. B is equal to negative 5. The way of factorizing this is you're going to put your B on the side here, and you're going to look at C. You're going to look at all the numbers that you can multiply, and you can get 24. 124, 2 and 12, 3 and 6. صح? لا, that's 4 and 6, sorry. 4 and 6, it is 3 and 8, 4 and 6, and that's pretty much it. All right? So these are the numbers that you can multiply in each other and you will get 24. But we have a negative sign here. So one of these values has to be minus, either this one or this one. All right, so one of them has to be minus. So what do we have to check for next? We have to see if these are going to be equal to our B value, which is minus 5. So let me actually bring our C here. And this is our B value. So now we need to relate it to our B value. So 1 minus 24 or 1 plus 24 or 24 minus 1, this will not get us the value. 12 minus 2, 2 minus 12, this is going to be 8, and this is going to be minus 8. It is not the value. 8 minus 3 is equal to 5. Okay, this is the correct value, but the minus is on the wrong side. 3 minus 8 is going to give us minus 5, which is the correct value. فمعناته بيكون عندنا minus 8 and plus 3. And this is what is going to be selected because it gives us the final answer of minus 5, which is our B value. Therefore, now we can do our factorization. Okay, so it's going to be x plus 3 times x minus 8 divided by x minus 8. And from here, it is very simple, very straightforward what you have to do. You're going to cancel this with this. You're going to be left with x plus 3. So the limit as x approaches 8 of x plus 3 is equal to 8 plus 3, which is equal to 11. All right. So as you see, you're going to have a quadratic equation. You're going to have to know how to do the factorization. In the case, actually, instead of c here, remember this as a times c, all right, is equal to 24 or minus 24. Why am I saying this? Because in this case, a is equal to 1, so it doesn't have any effect. But if you're doing factorization and you have a value for a, this is how you're going to be doing the method. And I explained that method very clearly in one of my previous sessions. You can refer to that video because I did. It takes a while to explain, but you guys can look at it and understand it clearly from a previous video there. عشان I don't waste time explaining it. But the idea here is for the limit. So you do your factorization. Once you do your factorization, you're going to cancel up and down. And then you're just going to plug it back in. One more question I'm going to do for the limit. The limit as x goes to 0 of x plus 5 over 3x. Now, in this case, this I will call case 3 and our final case. Limit does not exist. How do we know? We check every single case. So if we do case 1, we just plug in. It's going to be over 0. 3 times 0 is 0, so it doesn't work. Case 0, I should say, when we're plugging in, it doesn't work. Case 1, what was it? Square root, right? So case 0 was plug in. Never substitute. Case 1, square root of x. عندنا فوق أو تحت square root of x? لا. So we cannot use this, we cannot use this. Case 3, or case 2 is factorization. Can we factorize anything up or down? Nope, we cannot. If all these cases we cannot do, then it is case 3 and limit doesn't exist. Okay, so in this case, the limit is actually non-existent. Tamam? Very rarely you're going to see a case like this, but just in case you do, understand how to go through the process. ابدأوا من case 0 بعدين روحوا لcase 1 بعدين روحوا لcase 2 بعدين إذا كل هذول ما صاروا معناته you have your final case. Any questions about limits in general? Do you guys have any specific problem you want me to solve for limits before I move on to differentiation? Because this is pretty much it for all of limits. In any type of limit you might get, this is how it is. But طبعا يعني من ناحية factorization, you might have to factorize up and down. Or sometimes you might have to do the conjugate up and down, but I haven't seen that at this level. يعني it's just with practice, you're going to understand more and more. And always follow these cases, always. You always follow these cases. And you're always going to be able to find your limit for any type of case that you might get. All right. Any questions before I move on? Nothing? All right. I'll do actually one more question here. Let us do this. The last question, and then we're going to take a short break, and then we're going to start with differentiation. So x squared minus 6x divided by x squared minus 7x plus 6. So again, what are we going to do here? We're going to look at the cases, case 1, case 2, case 3, before we even solve it. So let's do that. أهم شيء إحنا عندنا denominator في البداية. Let's look at the denominator. So it's going to be 6 squared minus 7 into 6 plus 6. It is going to give us 6 squared is 36 minus 7 times 6, which is 42. 42 plus 6. If you notice, you put this in the calculator, or if you just calculate it, you can see that this is equal to 0. So we know that this is not correct. All right? We cannot substitute the 6 directly. Let's look at case 1. Case 1, we need a square root. We don't have a square root. But perfect. Skip. Case 2, factorization. All right, so let's start with factorizing x squared minus 6x over x squared minus 7x plus 6. Let's first factorize the numerator. The numerator is x squared minus 6x. We can take x as a common factor. All right, لأن عندنا هني x and we have here an x. All right, when you have more than one x, you can take it as a common factor. So if we're dividing, if we're doing the full way, this is how it's going to look like. Dividing by x here, minus 6x divided by x here. All right. If you notice, x and x will cancel here. Here the square root will go away because it's x power 2 minus x power 1, which is just x power 1. All right. So it is going to be equal to x into x minus 6, just like that. All right. Divided by طبعا x squared minus 7x plus 6. Same thing here, x squared minus 7x plus 6. All right. Again, factorizing the bottom, you can use just mod 5.3 if you like, but if I do it the way I usually do it, so our AC is equal to 6, 1 into 6, which is just equal to plus 6. All right. The factors of plus 6 are 1 and 6, 2 and 3. All right. And now our B value is minus 7. So which two values here will give me minus 7? If this is minus and this is minus, will give me minus 7. Because minus 1 minus 6 is equal to minus 7. So I know that this is factors that I need, the minus 1 minus 6. So I can rewrite this equation now as x minus 6 divided by x minus 1 times x minus 6. All right. If you are going to use mod 5.3, if using mod 5.3, the answer here is going to give you 1 and 6. All right. But you have to understand that you're going to do x minus 1 and x minus 6. This is the solution. We're not looking at the solution. We want to find the actual factor. So, and if you're using mod 5.3, the solution will be 1 and 6. But you guys have to do the minus. So it's going to be x minus 1 and x minus 6 because we're doing the factorization, not finding the solution. Okay? Coming back to this, now we can simplify this equation, x minus 6 and x minus 6, and we will be left with x divided by x minus 1. So now we can do the limit as x goes to 6 of x over x minus 1. So it's going to be equal to, we plug in the values, so it's going to be 6 over 6 minus 1, so it's equal to 6 divided by 5. All right, this is how you would solve for limits as usual. Let's take a 10-minute break. All right, let's make it a 7-minute break. Yalla. We'll be back at 8:05. All right. If you have any questions, I'm going to still be here, so you feel free to ask in the chat. I'm going to be looking at chat, but let's just take a break for you guys, عشان we can start with the new topic, which is differentiation. All right. Yes, this is recorded, and I will post it, inshallah, as soon as we're done with the session. Can you guys remind me when the exam is, the date of the exam? I think it's June 2nd, but I'm not sure. Can you guys confirm that? Sunday لا مو الأسبوع اللي الأسبوع اللي بعده. 9. It's the 9th of June. Oh, okay. So you guys have a lot of time to practice. That's good. Okay. I'll most probably I might be doing sessions towards the week before. If I need it, I will do extra sessions before the week of that. Another question I have is, did they comment on what is going to be in the exam? Did they say everything is coming? Do you know anything specific any teacher told you guys that might not come or I should avoid? If you do, just let me know in chat عشان ما أركز وايد عليه. أركز على more important concepts. يعني من ناحية differentiation أو من ناحية شيء ثاني. Is your exam fully multiple choice like last time? All right. If your exam is actually all multiple choice, which I think it is, you see everything that I taught you, this is the theory behind it. But there's a shortcut to all of what I just did. For any case you get, there's a quick shortcut that you can do, except in the case of case 3. All right. So make sure you know that it is definitely case 1 or case 2 or case 0. And then there is a shortcut. So case 0, it's very easy. All right. All you have to do is just find your, just plug in the number and you will find it. Let's say, for example, where did I start for case 1? Case 1, we found the answer to be square root 5 over 10, right? And it was the limit of x of 0. This was the question, okay? So this I will call the shortcut method. Again, this is nice for now, but when you reach degree, you're going to have to show your steps anyways. But instead of 0, all right, this is shortcut. Instead of 0, plug in a number that is very close to 0, like 0.0001, into x instead. So if I do that, يعني بيكون عندي square root of 0.00001 plus 5 minus square root of 5 over 0.00001. All right? And if I do that in the calculator, 0.0000001, square root of 0.001 plus 5 minus square root of 5 over 0.00001, you're going to get a value of, for example, what I got was 0.2236, whatever. And then when you go, you're going to have multiple choice, right? So you're going to have option A, option B, option C, and option D. One of those options is going to be the actual answer, which was what we found to be earlier. Square root 5 over 10, or 1 over 2 square root 5, for example, all right? So 1 over 2 square root 5 is going to be one of the options. Also, put this in the calculator and hit SD. So you're going to put 1 over 2 square root 5 and then hit SD. You're going to notice that the answer is going to be 0.2236 as well. Okay? It's going to be almost the same number, but there's going to be more decimal points when you do it in this case. Okay? Obviously, the more decimal points you put, the more accurate it will be, but this is a shortcut method and you can use this for anything. You can use this also for factorization. And for example, in this case over here, and then let's do it as well one more time so you guys see what I did. We know that this is case 2 after solving it, right? So we know for a fact that we can do this using factorization. However, if you forgot or whatever happened or you're just too lazy, or I'm not going to comment on that, بس تقدرون تحطون هنا عندنا الفاليو 8. So you can put 8.00000001 instead of 8 and find the answer that you will get. So you're going to put this instead of all your x squareds, huh? All of them. So it's going to be 8.000001 squared هني minus 5 into 8.000001 minus 24 divided by 8.000001 minus 8. And you will notice that you're going to get an answer. So when we solved this, our answer was 6 over 5. All right. So the answer was initially 6 over 5, which is equal to 1.2. Okay. Now, if we plug in this value, so 8.00000001. Don't put too many zeros because then it will just round it up to, or round it down to 8. All right. Usually use 6 to 7 zeros. That's more than enough. And then just plug it in for your x. So minus 5 into this, minus 24. Oops, I made a mistake. I need to start again. 1 second. So answer squared minus 5 into the answer minus 24 over 8.00, which is the answer minus 8. Feel like I did something wrong. I just don't know where. 1 second. Again, 8.000001 minus, oh, I forgot to square. Okay, minus 5 into this, minus 24 over this minus 8. I don't know why I'm getting 11. 1 second. Is my values correct here? Did I solve this correctly? Did I copy it correctly, bad? X squared minus 5x minus 24 over x minus 8. 1 second. Oh, it's the limit. Oh, wait, which equation am I doing? The answer wasn't 6 over 5. It was something else. 1 second. Con for what this one. The answer here was not, it was 11. 8 plus 3, which was 11. This was our answer, not 6 over 5. That was a different question. So the answer is 11. Once I put all of this in the calculator, I also got a value of 11. Okay, so this is a shortcut method. If you want to do it, it will save you a lot of time in the exam if it's multiple choice. If it's written or if they request steps, you guys have to have a general idea of understanding how to solve it, just in case. Now, let's move on to differentiation. Again, just before I move on, remember, make sure you know which case you are doing, because if it is case 3 and you do this method, you will get an answer, but it is incorrect. Because in case 3, there is no limit. The limit does not exist. So make sure you go through all the cases before you apply the shortcut. Yani make sure you know which case it is, then you can apply your shortcut. Now, let's talk about differentiation. So what is differentiation? Just a little bit of theory for you guys. Differentiation basically means the rate of change of a function with a specific variable. This is all this means. It means it is rate of change. Yani how much something is basically changing with respect to something else. All right? And it is usually given in this form. This is dy by dx. This is representing differentiation. Differentiation. Okay? So in this case, let's say we have an equation or a function y, which is equal to as simple as 3x squared. All right, a simple function like this. To find your dy by dx, or sometimes I will use y prime. This is just a different notation. And then for differentiation, the rule that you are going to apply is this. So we have our actual thing, which is 3x squared. The rule that you are going to apply is you're going to multiply by 2. Everything you're going to multiply it by 2 minus 1. This is your general form for differentiation. So when you have a basic exponential expression like this is the form that you are always going to do. So if you see it in the formula sheet, I believe it is something like this: n 3x n or nx n minus 1 in your differentiation in your in your formula sheet. All right, because you guys are going to be getting a formula sheet, this long formula sheet with everything. So see, it will give you all the equations, but you have to, this isn't enough to solve the exam. You guys need to know how to apply these equations as well. All right, so coming back to here, this is what you are going to do. You're going to multiply the exponent اللي هو هني الباور الأس original one, the 2 outside, and then you're going to subtract 1 from the power for your general form. So y prime is going to be equal to 2 times 3 x to the power of 1, or simply 6x. So this is the differentiation of 3x squared. Remember, the differentiation, when we say, let's say y is equal to 6, the differentiation of 6, so y prime, is going to be equal to 0, because constants do not change. What do I mean by that? And remember, I said there's a rate of change. The differentiation is you are finding the rate of change, yani how much this is changing. The 6 will never change. It will always stay 6. That's why the answer is the amount of change that will happen to it is 0. This is what is meant by differentiation of a constant. So if you have a constant value, yani any number, I think in the equation, in the formula sheet here, it is given as given as c, where c is a constant. It is always going to be equal to 0. If you have a simple equation of 5 times x, All right, you're going to apply the same exact formula here. And then, so y prime, or dy by dx, is going to be 5x. Remember, this is simply the same as saying 5x power 1. You're going to multiply 1 out here, and you're going to subtract 1. So you will be left with 5, because 1 times 5 is 5, x to the power 0, or simply 5. So you can simply say whenever you see any number 8 times x, the differentiation of it is simply just 8. Okay? This is how you do differentiation for very simple values, simple formulas. Let's look at another example. So I'm usually using y. Sometimes they are going to use f of x. This basically means it's a function of x. All right? And don't let this confuse you. It is the same as saying y is equal to. All right? Yani if you guys get confused by a question, if I say f of x is equal to 6x to the power of 7 over 3 مثلا. You guys, if it's too confusing, you guys could just write it as y is equal to 6x to the power of 7 over 3. All right. It is the same thing, but you need to get used to looking at this. This basically means it is a function of x. معناته بيكون في equation with a variable which is x. That's all this means. تمام? So let's find the differentiation of x, or f prime of x, or simply y prime يعني. Again, you will apply the same exact thing in this case. When you have simple exponential, you will apply the same case where you're going to do -1 and you're going to take this and multiply outside. So 7 over 3 outside. All right. So it will be equal to 7 times 6 over 3 outside. X, 7 over 3 minus 1, that is going to be 4 over 3. Again, you can use a calculator for 7 over 3 minus 1, but you guys should already know how to deal with fractions. And remember, you need to remember all your exponent rules. You need to remember that if you have x power minus 5, this is the same as 1 over x power 5. لأن you need to understand, and I'll show you why right now. You need to understand how to move your x up and down. So let's just simplify this differentiation. So 7 times 2, which is 14x, 4 over 3. This is your final differentiation. All right. If you have a function f of x is equal to 1 over x to the power of 7. And then, for example, a second, just want to double check something real quick. All right. So let's say we have this function, x power 7. This is the same as writing x to the power of minus 7. Now, I know when you guys are going to look at it in this form, it's going to be very confusing. So remember, you can always move the x upwards as long as you put a minus sign here. Now, this is a simple form. So you can do f prime of x, اللي هو differentiation ماله, is x minus 7. Applying the rule, this is going to become -1, and the -7 with the sign, all of it is going outside over here. All right. So -7 is coming outside here, multiplying it with your function. So if we simplify, it is -7x. -7 minus 1 is -8. And this, again, you can do it the same idea. You can take it back down. It is going to be -7 over x plus 8. The reason you need to know all of this is because in multiple choice, they might give you this as the answer or this. You need to know how to move the 8 up and down, or the power up and down for the variable x. Okay? This is obviously for the general form. Again, if you have the rules for differentiation, let's say you have 3x cubed minus 7x squared plus 2. All right? For example, we have this. You will differentiate each one by itself. Okay? You can differentiate each one by itself. The plus will not, and the minuses in between, does not affect the differentiation in this case, when they are just simply by themselves. So what can you do? F prime of x. Sorry, this is f of x. This is the actual function, or y. And then f prime of x is going to be, you will differentiate the first one, so it's 3x power 3 minus 1, and you will take the 3 and multiply it outside as well. And then you will do the same thing for the next one, so minus 7x, all right, squared. Again, same thing, you're going to do minus 1 power here, you're going to take it outside here and multiply it as well. And plus 2, what does plus 2, what happens to a constant? There is no change, so the constant becomes 0. When you have a constant, it becomes 0. Tamam? So simplifying this is going to give us 3 times 3, which is 9, x, 3 minus 1 is 2, minus 2 times 7 is 14, x power 1, or simply just x, because 2 minus 1. This is how you would differentiate if you have minuses and pluses in between. You will differentiate each one by itself. Tamam? Another thing, and remember, do not get confused by signs. So let's say, for example, we have minus f of prime of x, or let's say y is equal to 305 x power 4. Tamam? Actually, let's use a different number. X squared minus 8 over x power, I don't know, 3. So we have 5x squared minus 8 over x power 3. If we want to find y prime, remember, you can do each part by itself. So it's going to be 5x squared. The 2, you're going to take it out, and then you're going to do minus 1. Okay? Keep it always in brackets while you're practicing so you don't make any confusion if there's a sign, and you'll see what I mean. Remember that this is the same as 5x squared minus 8. We're just going to take the x up. We put a minus sign. All right? So this was the first part. Now the second part is the minus 8 x power minus 3. So when you are taking the minus 3 outside, remember it is going outside with the sign. So do not make a confusion in the sign. Most of the time, people make mistakes with the sign when they are differentiating. Minus 1. All right. Even degree students till today, they are making mistakes when they are differentiating because they either forget the sign or they plug it in incorrectly or whatever. So make sure that the sign is correct, because now when you simplify this, so the first one is just 2 times 5, which is 10, x power 1, minus and minus becomes plus, so minus times minus becomes plus, and 3 times 8 becomes 24, x power minus 3 minus 1 is minus 4, so you can write it again as 10x plus 24 over x power 4. All right? These are the main rules for the general form for when you just have a simple power and a simple constant, or you're adding and subtracting. This is what you will be doing. Okay? Now, what about in the case of when you have something like this? Y is equal to, actually, I'm not going to explain this yet. I want to explain that at a different time, which is substitution. Okay, let's look at this one. Y is equal to the square root or the cube root of x plus 2x minus 1. Remember, cube root, this cube root over here, this part, you can write this as 1, you can write this as x to the power of 1 over 3. This is the same exact meaning. Same thing for x squared, or square root of x, it is equal to x to the power of half. All right? Remember, when you have a square root or a cube root or whatever root, no matter the size, it is simply just in this form. So you can simplify this, and always try to simplify it so that you have it in exponent form, because it makes it much easier to differentiate. All right? So it's x power 1, 3 plus 2x minus 1. All right? But now we can do the y prime. This is y. Y prime is, again, x power 1 over 3 minus 1. We'll take the 1 over 3 multiply it outside, plus 2x, same idea again, 2x, you guys can directly do it since this is x power 1, you know that it's just going to be 2, minus 1, it's a constant, it becomes 0. Okay, so simplifying this is going to be 1 over 3 x power 1 over 3 minus 1 is going to give us minus 2 over 3. Notice now we got a negative exponent, plus 2. We can further simplify this. It will be 1 over 3x power 2 over 3. We just eliminate the minus. And we can write it again, plus 2. And we can further simplify it by going in the opposite direction. So remember I said x power 1 over 3, okay, is squared. So let me write that actually here. So square root of x is equal to x power 1 over 3. Same thing, x power 1 over 3, we can plug it in, transform it back into this form, which will be 1 over 3 cube root of x squared. And now here we have at the top the exponent x squared, and at the bottom this is going to be our cube root, of course, plus 2. Okay, so the idea here is making sure you understand how to mess around with the exponent, knowing what the exponent means. شو معناته 2 over 3? Knowing that when you have a denominator in your exponent, that means it's the same as a square root or a cube root. Knowing when you have a minus, معناته you can take it down, because you guys have a multiple choice exam. This could be the answer, or this could be the answer, or this could be the answer, but you guys need to know that they are all the same, so you know how to find it. All right. That's pretty much it for the general form so far. So let us move on to, so this was the general form, all right? This was, move this a bit up. This is the first form, which is the general form. All right, اللي هو بما معناه, we are using this equation over here for everything, which is y prime is equal to nx n minus 1. All right, this is the general form. Now, let's look at the trigonometric forms. So this is two trigonometric functions. Okay, لو ما تتذكرون trigonometry اللي هو معناته sine, cosine, and tan. Also you have sine inverse, tan inverse, cosine inverse. Let me go in order. And tan inverse. And you have also 1 over sine, which is equal to secant. All right. And you have 1 over cosine, which is cosecant, given as CSC, cosecant. And then you have 1 over tan, which is known as cotan. Okay, so these are the trigonometric forms. I am not sure if they give you hyperbolic بعد, بس خلوني أتأكد من الفورمولا sheet. Nope, you guys are not dealing with hyperbolic sine and hyperbolic cosine, alhamdulillah. All right, so that's pretty much it. All right, so these are all your trigonometric signs. So when you have this in your function, زين, طبعا this is x, يعني هني بيكون x of x of x of x of x. All right. When you have one of these functions, you're going to have to be applying the trigonometry form. Now, obviously, these are also given here. And where are they? All the trigonometry here on the right side. You will notice that all the way you have sine of x, cosine of x, tan of x, cotan of x, secant of x, cosecant of x, sine inverse of x, cosine inverse of x, and tan inverse of x. All right. So all of these are going to be here. Okay, the right side of this. All of these are going to be, this is going to be given in the exam, but you guys need to make sure you understand how to solve for this. So let's start with the simplest form. Let's start with sine of x. So let's say y is equal to sine of x. Okay, If y is equal to sine of x, that means y prime is going to be equal to cosine of x. Very simple. So when you have sine, it is going to go to cosine. The next one is y is equal to cosine of x. And then y prime is going to be negative sine. So the difference is here, when you're going from cosine to sine, you are going to have a negative value. All right? When you're going to sine to cosine, there's no negative value, but from cosine to sine, the answer is going to be a negative value. How about if we have y is equal to sine 3 of x? What you're going to do is, when you want to do y prime, it's going to be also from sine, it is going to change into cosine of 3x. Nothing changes inside, all right? So this is like this. The 3x will not change, but the 3, you are going to take it outside and multiply as well, all right? So this is the only thing that will be changing. So y prime will actually be 3 cosine 3x, okay? So if you have a constant here, you're just going to multiply the entire function by that constant as well. Same thing for cosine. So let's say y is equal to cosine of 2, or let me say minus 2x. Y prime is going to be minus sine, right? Minus sine of minus 2x. It doesn't change. What's inside doesn't change. What will change is now the minus 2 will be going outside here as well. So now you're multiplying by minus 2. So again, be careful with the signs. I chose minus 2 intentionally. If you notice here, we're going to have minus and minus, so they will cancel out. So your answer will be 2 sine minus 2x. Remember, inside, nothing changes. The inside of the cosine will stay the exact same thing inside here. It will never change in differentiation. The outside is what will get affected with the values. All right? The required is only cosine and sine. Yani you don't want me to go over all the rest of these, the tan and cosecant and cotan, and بصراحة يعني even in degree you guys are not going to be covering any of these, all right? And I don't want to waste time going over these, but I saw them in the worksheet. That's why I thought they were going to be here. Either way, if these come, you guys can see them directly from the formulas here, and you can just simply apply them. Just one thing you need to know about the formula sheet, when they are saying the letter C here, this basically means it's a constant value. معناتها it could be 5, it could be 2, it could be minus 3, it could be any value, any number. So you guys can directly just apply it using the formula sheet if you understand the formula sheet, all right? There is no memorization here at all. There is more understanding than memorization. Same thing, يعني إذا أعطوكم secant of C of x, you will be able to solve it directly. But there are going to be some more rules that are going to apply later on when you are combining and multiplying, and we will see that later with the product and co. So since you have sine and cosine, this is literally all you need to know. All right, for sine and cosine, this is what you need to know. So basic sine is going to be basic cosine. Basic cosine is going to be negative sine. If you have a number inside, sine will become cosine, but the number inside, you're going to multiply it outside. All right. And if you have cosine, it's gonna become minus sine, and the number inside the constant, you're just gonna multiply it outside. All right. And that's pretty much it. So let's say if I give you a question now, y or f of x is equal to, by the way, it's not necessarily x, all right? Sometimes they can say f of s is equal to sine 3 sine 2s minus 5 cosine, let's put 3s. Why not? And then, for example, they can give it to you in terms of s instead of x. Or maybe not even s, maybe they can give you in terms of theta, when it comes to sine and cosine, all right? It doesn't matter what the variable is. It doesn't matter. Okay, but the differentiation will become now df of theta by d theta, because now the changing variable is theta, all right? This is just extra information for you guys to know, or you can simply just say f prime of theta is going to be equal to. So again, 3 sine 2 theta is going to become cosine, so 3 cosine 2 theta, nothing will change here, all right? But what will change is the 2 inside. You're going to be multiplying it outside as well. All right, minus 5 cosine 3 theta. The cosine, now this is very important, all right? So this is minus 5 cosine. This cosine becomes sine, but it becomes minus sine. So it becomes minus times minus again. All right. This minus outside, we kept it outside. All right. So let me highlight it so you guys can see the bigger picture. This minus is this minus. All right. The minus inside is due to the rule of cosine. When it goes to sine, it becomes minus. Okay. So it becomes minus 5 sine 3 theta. And on top of it, we're going to have to multiply 3 outside. So it's going to be times 3. Okay? So this is where it becomes a bit tricky with the signs. All right? So just make sure you're writing it properly. Here we have 2 times 3, which is 6 cosine 2 theta. Minus and minus will become plus. 3 times 5 becomes 15 sine 3 theta. Okay? So this is where the trick will happen. The minuses, the signs, making sure you have the right signs, especially if inside was also negative, it's going to be minus times minus times minus. So it's going to be plus and then minus times plus, which is minus. But you get the idea. Just make sure you are taking care of the sign. All right. So this is the case for sine and cosine. Anything else that there might be? Nope, that's all I can think of. Example, let's do sine. I don't think that's going to be coming for you guys. Are you sure about? Okay, so the question was y is equal to sine cubed of 2x squared plus 2x plus 5. I don't think you will ever get a cubic sine. I don't think so. لأن the solving method for it is very long, and it is يعني even sine squared, you're going to have to use a lot of relations so that you can solve the. It's not as easy as you might think. I am not sure if this is actually going to come in the exam. That's why I don't want to waste time solving this. It will take a long time and everyone will get very confused. I don't know where you got that example of, but double check with the teacher just in case. If they say you will get sine squared, sine cubed, sine power 7, sine power whatever, let me know. And the next session, I will make sure I cover it. But I am 99.99% sure you are not going to get that in the exam. Okay? All you need to know is sine power 1. You're not going to get sine power 2, sine power 3. What you might get is inside, you're going to have a different power, and I will cover that. Or you might have a different function, and I will cover that in a bit. But that I want to cover in tomorrow's session. Today, I want to cover the basic rules only for each of the cases. So the first one was the general form that we finished. Now we have covered trigonometric functions, or the ones at least that are important. And this is how you would solve it, especially if they're combined. Now let us look at the exponential functions. Exponential function. What do I mean by the exponential function? I don't mean that it's x power something. No, I mean that you have your e to the power of x. Okay? This is what is meant by an exponential function. And this might be the easiest differentiation you will ever have to do. Why? Y is equal to e of x. Y prime is also equal to e of x. That's it. It's that simple. For a basic e of x, the differentiation of it is also equal to e of x. All right? No matter how many differentiations you do, it will never change because the rate of change is equal throughout everything. It is always going to be the same in an exponential function. But when will it change a little bit, very slightly? It's when you say, for example, e to the power of 3x. We will apply the same idea that we learned in the cosine and sine. We're going to be doing e to the power of 3x. Nothing will change, but you will take this 3 and multiply it outside. That's it. So your y prime is going to be equal to 3 e power 3x. This is how it is for any exponential function. The only thing you guys need to watch out for is the sign and when they want to mess around in exponents. So, for example, let's say I give you that you have 1 over e power 3x, for example, or let's choose another different number. Let's say 5x. Let's say this is your y. Okay? If I give you this as your y, you need to understand that this is also equal to e to the power of minus 5x. And now you can simplify it much easily. So y prime is going to be equal to e to the power minus 5x. Nothing changes. Only thing, since we have a constant here, with the sign, it is going to come outside. Fair? It will be equal to minus 5 e minus 5x, which is equal to minus 5 over e to the power of plus 5x. Tamam? This is where confusions might occur. All right? Is this clear? I hope so. I hope that this is clear. Let's see what else is there. Oh, okay, yeah. So this is in the case of this exponential function, when you have the base of e, all right? But what if we had a number instead? Let's say we had 5 to the power of minus 2x cubed. Actually, let's just keep it as x. I don't want to go into the cubed yet. Later, I will explain why. But let's say we have this 5 to the power of minus 2x, right? This will not be just 5 to the power minus 2x again. This is not right, all right? So this is our function, y is equal to 5 to the power e minus 2x. You're going to have to apply the same exact thing that we used to apply earlier, all right? So we are going to get 5 minus 2x, right? This will still be there. This will not move, but you're going to be multiplying it by ln. This is the first thing. You're going to be multiplying it by ln of the base here, this value over here, which is 5, right? You have to multiply it by ln of 5. Tamam? And you're going to have to multiply this outside as well. So minus 2 outside. All right? So again, I repeat, the first thing is your 5, your base is no longer e. All right? You no longer have a base of e. You have a base of 5 now. This means that you're going to have to do the ln of this value and multiply it outside. And on top of it, whichever value you have up here, you're going to multiply outside as well. All right? This is what the trick is for any other base if you have other than e. So y prime would be minus 2 ln 5 times 5 e minus 2, sorry, 5 minus 2x. Okay? This is how it will be. And that's pretty much it for exponential functions. You can either have it in the term of e. When you have e, it is the most easiest way, all right? It's just going to be the same thing. If you have a constant, you take it outside. And you're going to have the case of 5, when you have a normal base, okay, not e. And you can have 5, 10, any constant. It doesn't matter what the value of it is, 50, 30, as long as there's no variable, huh? And you cannot x power x, forget about this. You're not going to be getting this right now. Trust me, you don't even want to know how the differentiation of that is. But for now, when you get a constant other than e, because remember, e is also a constant, but it's a natural constant, yani it's a function. but like pi. But here, when you get 5, what you're going to do is, just so you guys understand, so you guys get the idea. If this was e to the power of minus 2x, e to the power of minus 2x, and we applied this form is correct, by the way. So we can apply this form. It is going to be minus 2 ln of e times e to the power minus 2x. All right, if we applied the same form that we applied here. Okay, this is just some extra information. Ln e is equal to 1. So you will be remaining with minus 2e minus 2x. All right, so we are technically applying the same form. So this is the correct form for all exponential functions. However, when it comes to e, because ln of e is equal to 1, we can simply simplify it and have it to be this directly. All right, this is the whole idea. Okay. And that's pretty much it. So if in the case if we don't have e, the ln of that number is going to be multiplied by the function, and as well whatever the power constant is, we're going to be multiplying it outside. The last part before I conclude, so we have reached now exponential form. The last part, which is 4, is the logarithmic functions. Right? Logarithmic functions. So what are the logarithmic functions? Logarithmic functions are simple. Either you have log of x or you have ln of x. All right? I'm going to do basic ones for now. I don't want to confuse you guys too much. I'm going to just do the basic one for now. So when we say log of x, this basically is the same as saying log base of 10 of x. All right? Keep that in mind. So the y is equal to log of x. Excuse me. So log of x is basically the same as saying log 10 x. All right? Before we even go to log, let us start with the easy one, which is ln. So ln, remember, if you remember from logarithmic from last time or from a while ago when I taught you guys, I don't know if it was this semester or last semester, but logarithms, ln is the same as saying log, yani ln of x is the same as saying log of base e of x. All right, this is what ln x basically is. All right, so keep that in mind. So let's say we have a function y is equal to ln of x. Y prime is going to be equal to 1 over x. This is the rule when it comes to ln. Okay? It is going to be 1 over x. In other words, this is saying that the no, that would confuse you guys too much. All right, but this is the idea. If you have ln, it's very simple, very easy, piece of cake. It is 1 over x. But keep in mind that y ln 4 of x is also equal to 1 over x. It is not equal to 4 over x, all right? And I will explain this much more in detail in next session, and I will show you why. But I don't want to explain that concept right now. But keep in mind that when you have just 4x, it's going to stay the same differentiation, all right? بيكون 1 over x. So now what about log? What about log of x? All right. Let's say we have, instead of log 10, let's say we have log 4 of x. Okay. Simply, how are we going to do this? It is going to be the same idea as ln. It is going to be 1 over x. Okay. But we are going to multiply by the ln of the base here. And let me write that here. So we're going to be multiplying with the ln of the base here. So times ln, make it a bit more clear. So this base 4, you're going to get ln times 4. Okay? This is the only difference. So now it doesn't matter what the base is. It doesn't matter which log you have. This is how you do it. Because remember, the log y of ln x is equal to log e of x, right? Log e of x. And we already established that it is 1 over x. How did we get 1 over x? If we apply the same rule, y prime, sorry, this just to make clear, this is y prime. I don't want there to be any confusion here because this is not equal to y of x. This is just y prime is equal to this. All right? This is where the 4 came from. So let me write this a bit more neatly. Y is equal to log base e of x. This is the same as ln of x, right? So we said earlier, this is what ln of x is. So if we do this in the same form, y prime is going to be equal to 1 over x ln or of the base e. But we already established earlier that ln e is simply equal to 1. That's why the y prime is equal to 1 over x. Okay? This is the whole idea. So when you have ln, it's simply 1 over x. If you have log of any type of base, all right, it is going to be 1 over x times ln of that number. Okay, I'm going to do a lot more of log equations later on and ln equations with a lot of more confusing things inside. I don't want to confuse you a lot because there's a new concept I want to introduce which will make it all easier for any type of integration. I think I'm going to stop at this point for now. If you guys have any questions, feel free to ask about differentiation or about limit. For the next 10 minutes, I'll be free to answer any of your questions. You don't have log, I just saw that. Well, now you learned something new. And then I'm gonna talk to the coordinator as well. I'm gonna talk to him about technical math or her, and I will see what should be involved and what shouldn't be involved, so I know what I should be focusing more on. Anyways, I'm stopping